Hello students, welcome to the physics class. Today we are going to discuss NCERT questions of class 10. I will start chapter wise. At first we will be doing light, that is reflection and refraction. I will be giving you the solving part of exemplar as well as the last part question, that is chapter end questions. So all the solving part will be there. Wherever there are problem solution, I'll show you that. So my dear students, let us start. If you go to your NCERT book and page number 168, you will find few questions out there, out of which there are two problem solving question. The first question is the radius of curvature of the mirror is given to you, that is how much? 20 centimeter. What is the focal length of it? So we have to find out the focal length. So if you have studied the mirror formula, okay, and the mirrors, you will see that the focal length f is given by radius of curvature divided by 2. It falls on the midpoint of focal length and the pole of the mirror. So your radius of curvature is 20 centimeter divided by 2. So right answer for this one will be 10 centimeter. So the focal length is 10 centimeter. Okay. In the same page number, there is another question. I will repeat the question for you also. Let me rub this one. This is the answer, 10 centimeter for this question. Next question is asking you that name the mirror which can give you erect, virtual and enlarged image. So which mirror can give us? This is only concave mirror. See, virtual image can be formed by convex mirror as well, but it will not be an enlarged image. So there is a condition where concave mirror give us the virtual image which is enlarged. So if you draw a concave mirror, right? So this is your concave mirror. This is the principal axis, this is the pole. Suppose this is focus and this is radius of curvature or the center of curvature. This is the radius of curvature r. Okay. Now, when the object is in between focus and pole, then only you have this option. So once the rays strike parallel to the mirror, it will pass through the focus. My rays might not be straight, you have to use scale and pencil to draw the rays, and another one will pass through the center of curvature after striking the mirror. It will come back because it falls normally. Whenever it passes through the center of curvature, it falls normally. So if I extend this one, see, these are the two divergent ray, right? It will keep on diverging. So divergent ray comes from a point, right? So that point will be my virtual point. If I extend it on the other side, this is the image you will form for AB. If this is AB, this is A dash, B dash. So this is the condition where a virtual erect image is formed. Now in this chapter, if you go to an example 10.1, you will see that there is a question. Problem based question. It is asking that if you have a convex mirror used for rear view on an automobile, has a radius of curvature 3 meter, right? If the bus is located 5 meter from the mirror, so radius of curvature is given and the bus position is given, that means the object position is given 5 meter from the mirror. Find the position, nature and size of the image of the bus formed on that rear view mirror. So how you are going to approach this one? For that you will come to the concept. We will use which formula? Mirror formula. Remember one thing, according to sign convention, convex mirror has got positive focal length. So your focal length will be, radius of curvature is given 3 centimeter. So 3 divided by 2, sorry, it's in meter. So it will be 1.5 meter. This is your focal length, right? Now once you know the focal length, you know also the object distance. Object distance is always against the incident ray according to sign convention. So it will be minus 5 meter. If you look at the question, it is given minus 5 meter. So what you are going to do? You are going to use the formula, mirror formula. Mirror formula. So 1 by V plus 1 by U is equals to 1 by F. So we need to find out V, right? So 1 by V, it will be minus 1 by 5, focal length is 3 by 2. So it will be, if I put 3 by 2 at the denominator, so it will be 2 by 3, 2 divided by 3, or you can put directly 1.5 also, it is up to you. So 1 by V will be equals to 2 by 3 plus 1 by 5, right. So your LCM will be 5 into 3, 3 get cancelled, 5 into 2 is 10 plus 3. So your 1 by V will come as 13 by 15. 10 plus 3, how much? 13, and 5 into 3, 15. So your V will be 15 divided by 13. 15 divided by 13, you calculate, it will be 1.1. So your 13, 1.20, so 1.1 meter, fine. So the image which is formed, which will be 1.1 meter. The distance of the image will be 1.1 meter. Now the question is, what is the nature of the image? Image is positive, it is positive, right. So it will be virtual and erect, it will be virtual and erect. Now what will be the size of the image? That you have to calculate. You need to know magnification for that one. So you need to know the magnification. Magnification of the mirror is given by minus V by U. Now your V is how much? 1.1, and your U is how much? 1.5, but it will be minus, right. So minus minus get cancelled, you will get plus 0.23, 0.23 if you calculate this part. So can you see, the magnification is less than 1, but the magnification is positive. When magnification is positive, it means an virtual image is formed, but when it is less than 1, the image size is smaller compared to that of object. How much smaller? By a factor of 0.23. So this is a very important question from NCERT. This type of question comes from ray optics, that is your reflection and refraction. Now we will move to the next question. Again in the same chapter, if you go to example 10.2, you will see that an object 4 centimeter in size. What is the size of the object? 4 centimeter is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. Again the size of the object is given to you. In the question it is asking solution, always write down given, always write down given, what is given to you. If you know what are the things given to you, then it is easy for you to understand or easy for you to approach the solution. Now if you want to cook something, suppose you want to cook chicken, you must know the ingredients of the chicken, right. So when you have all the ingredients of the chicken, you can cook the chicken very nicely. So that's what in the given also you need to know what are the things given in the question. So object height is given, that is size 4 centimeter, and also object distance is given, u equals to minus 25 centimeter. Yes or no? Object is taken as negative, and it is a concave mirror. So focal length will be minus, see, if you see the question, it is given to be 15 centimeter. Okay. Now what distance, it is asking that at what distance the screen has to be kept so that a nice image is formed. So, image distance basically you have to calculate, and we have to tell the nature and size of the image. So, how you are going to calculate? So, you need to calculate V again. So, what you are going to do? You are going to use again the mirror formula here. Mirror formula. What is mirror formula? 1 by V plus 1 by U is equals to 1 by F. V we have to calculate, U we know, U is 1 by 25, that is minus 25, that is why I put a minus sign here, and focal length is given to be minus 15. So, 1 by minus 15. So, ultimately you will get 1 by V 1 by 25 minus 1 by 15. Okay. So, 1 by V will be equal to 25 into 15. So, 25 cancel out. If you take LCM, it will be 15 here minus 25. So, 1 by V will be equal to minus 10 divided by 25 into 15. So, if I cancel it out 2 times, 15 with 3 times. So, 1 by V will be equal to minus 2 by 75, right or not? 25 into 3 is 75. So, finally, your V will be equal to minus 75 by 2. How much it will be? So, it will be 37.5 minus 37.5. So, if the image distance is negative, then real and inverted image is formed. Make sure you know that. Image distance is negative, real and inverted image is formed. Okay. Now, what will be the size of the image? Nature we found out that is real and inverted. Now, the size of the image will be, we know magnification is equals to HO by HI by HO, height of the image divided by height of the object. So, HI by HO is equals to minus V by U, right. You need to calculate HI. So, your HI will be equals to minus HO into V by U. So, HO is given to you, right. HO is given to us, the height of the object is 4 centimeters. So, I will put 4 here, and V is given to us, we have already calculated minus 37.5. So, it will be minus 37.5 divided by U is also given to us minus 25. So, once you calculate this one, my dear students, you will see that at the denominator it is coming out to be plus 150 divided by 25. So, it will be how much? Minus 6 centimeter. This is the right answer. Height of the image is coming out to be 6 centimeter, which goes to prove that if you see the object height is 4 centimeter, image height is 6 centimeter, means an enlarged image will be formed. Height of the image will be large, although it will be real and inverted. Negative sign indicates that it is real and inverted. Now, let us move to the next question. Okay, find the focal length. If you go to page number 171, you will see that there is a question saying find the focal length of a convex mirror when the radius of curvature is given to be 32 centimeter. So, for a convex mirror, mark it. Okay, the sign convention for convex mirror R will be equal to positive 32 centimeter. Now, focal length is equals to R by 2. So, plus 32 divided by 2, which is equals to plus 16 centimeter. So, focal length is equal to 16 centimeter for concave convex mirror, not concave, convex. Repeat, it will be a convex mirror. So, now just below that you will find one more question which is saying that a concave mirror which is 3 times magnified. So, 3 times magnified means what? magnification is given to be how much? 3. Okay. Real of enlarged real image of an object placed 10 centimeter in front of it. Okay. Now, object distance is given to be minus 10 centimeter. Okay. Again, if you read the question properly, it says like that. As I am reading the question from the screen, it's saying that a concave mirror produces 3 times magnified enlarged real image of an object placed 10 centimeter in front of it. It is a real, right? So, it will be magnification will be minus. Okay. Now, if it was a virtual, then would have been positive. Now, where is the image located? Now, you have to calculate the image distance. So, if you need to find out the image distance, what you will do? You will say that we will use the formula m is equals to minus v by u, right. So, as m is given to be 3 and you already know, which is how much? Minus 10. So, your v will be equals to plus, the minus will go to the other side, it will be minus 30 centimeter. So, your v is minus 30 centimeter. Very easily can be calculated from the magnification part. So, that is it. This is how you can find out the location of the image from this question if you see page number 171 of NCERT. Now, if you move to page number 176, you will find few questions, where question number 1 out of that box says that a ray of light traveling in air enters obliquely into water. Does it bends away from the normal or towards the normal? So, ray of light was coming and it strike the interface where there is a water on the other side. So, what will happen? There will be refraction. So, what you need to do? You need to draw a normal which is perpendicular to the surface, to the plane separating to the surface separating the air medium and the water medium. This is medium water, right. So, this angle is angle of incidence. So, whenever light travels from the rarer medium to the denser medium, air is rarer because the density is very less out here, water is denser because the density is very more, because water molecules are closely packed. Okay. So, what will happen? It will bend towards the normal. So, this will be your angle of refraction. So, the right answer for this question is towards the normal, right. Now, let us move in the same box. Next question, it says that light enters from air to glass. Now, it is again going from rarer medium to the denser medium. Glass is a denser medium. Okay. Having refractive index 1.5, refractive index is given to you. Refractive index is 1.5. Okay. What will be the speed of light in the glass? That is what you have to calculate. Okay. We know refractive index is equal to speed of light in vacuum, or sometimes we take it as air also, divided by speed of light in medium. Okay, speed of light in vacuum is always constant, which is 3 into 10 to the power 8 divided by V, the speed of light in the glass. In the medium means it is in the glass, right. So, what you need to calculate? V, take V on the other side, 3 into 10 to the power 8 divided by refractive index. So, 3 into 10 to the power 8 divided by 1.5, so which is 2 into 10 to the power 8 meter per second. So, this is the right answer for this question. Now, if you go to example number 10.3, you will find questions from lens. So, let us see what are the questions. First question saying that a concave lens has got a focal length of 15 centimeter. Focal length for a concave lens, if you go to sign convention, if you study sign convention, you will see it is minus, so minus 15 centimeter given, right. At what distance should the object from the lens be placed from an image of 10 centimeter from the lens? Image distance is given to be 10 centimeter. Okay. Also find the magnification produced by the lens. So focal length is given, image distance is given, and you have to find out the magnification. Okay. For which lens? Concave lens. As we know, in case of concave lens, all the images are formed against the incident ray, right. So the image distance will be minus, right or not? If you check the lens, all the images are formed on the left hand side only. Now lens formula you need to use out here, you need to find out the object distance. Lens formula says that one by V minus 1 by U is equals to 1 by F. 1 by V is given to us minus 10, minus 1 by U, you have to find out, and F is given to us minus 15, right. So 1 by U will be equal to 1 by 15, that is your F, so 1 by 15, right, minus 1 by 10. Now you start taking the LCM. So 1 by U will be equal to 15 multiplied with 10. So it will be 10 minus 15. So 1 by U is equal to minus 5 divided by 15 into 10. So it will be 2 times, U will be equals to minus 30 centimeter. So you got your image object distance, right. Also find the magnification. Now magnification would be easy for you, because magnification for the lens is given by V by U. Now how much is V? V is minus 10 centimeter, minus 10. How much is U? U is minus 30, put minus 30, cancel it out, it will be 1 by 3. So it will be how much? 0.33. So the image which will form virtual first, and the image size will be small compared to that of object, because magnification is less than 1. So we have found it out. Now let us move to the next question. A 2 centimeter tall object, if you go to example number 10.4, you will find one question that a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. Convex lens means, given, if I write down, focal length is 10 centimeter, convex positive, and height of the object is given to be 2 centimeter. That is the object of the tree or anything which is kept on the principal axis of the convex lens. The distance of the object from the lens is 15 centimeter. Distance of the object U is given to be 15 centimeter. But U is always minus if you take against the incident ray. Find the nature, position and size of the image, also find its magnification. So again we will be using the same formula, my dear students. 1 by V minus 1 by U is equals to 1 by F. Lens formula, we need to find out V. 1 by V minus into minus is plus, 1 by 15, U is minus, right, minus into minus is plus, which is equals to 1 by 10. So 1 by V is equal to 1 by 10 minus 1 by 15. So if I start taking the LCM, it will be 10 multiplied with 15. So 15 minus 10, right. So the right answer is 1 by V, which will be equal to 5 divided by 10 into 15. So it will be 2 times. Now if you calculate V from here, V will be equal to 30 centimeter, right? So which goes to prove that in case of lens, when there is a positive sign in the image distance, that means it is forming on the other side of the lens. It is forming on the other side of the convex lens. So if you calculate image distance, now you need to know the magnification. Magnification for lens is V by U. V you know that is 30 and U is minus 15. So it will be minus 2. So more than one, an enlarged image is formed. M is negative, that means real and inverted image is formed. Fine. Now let us move to the next question. Now if you want to see the questions from power of a lens, you will see a box in the NCERT where questions are written. First question, it says define one diopter power of a lens. So this is not required, this is a question. I will just solve problem solving questions as I told you in the beginning. So in the next question you will see there is a very good question given. A convex lens forms a real and inverted image at a distance of 50 centimeter from it. Real and inverted image, which lens? Convex lens at a 50 centimeter from it. So V is equal to 50 centimeter. Fine. Now where is the needle placed in front of a convex lens if the image size is equal to the object side? One more thing is given, that height of the image is equal to the height of the object. This is one important part given in the question. Also they are asking find the power of the lens. So first of all we will solve in this way, that if this one is equal, magnification will be 1, Hi by Ho, these two are same, M will be equals to 1. So Hi by Ho also is equal to V by U. Now first you have to see what kind of image is formed, real and inverted. So this one will be minus 1, right? So your V will be equal to minus of U from this equation. Fine. So what you will do, you will use the formula of lens only to find out the focal length. Once you know the focal length, you can calculate the power of the lens. 1 by V minus 1 by U is equals to 1 by F. So 1 by V is how much? Given 50 centimeter, put 50. How much will be U? U is minus of V. So it will be plus 1 by 50, which is equals to 1 by F. So from here 2 will be LCM, or sorry 50 will be LCM, cancel it out, 1 by 25 is equals to 1 by F. So your F will be equals to 25 centimeter. Just see whether it is in centimeter or meter. Yeah, it is in centimeter. Now if you want to convert this one in meter, how much F will be? F will be equal to, divided by 100, 0.25 meter. This is how you calculate the focal length. Now if you know the focal length, you can calculate the power as well. What is the power? Power is given as 1 by F, and your F is how much? 25 centimeter. If I write down 25 centimeter, let me write it down, easy for you. You need to convert this one into meter, right? So how you will do? 1 by 25 divided by 100. So it will be 100 by 25. So the right answer is coming out to be 4 diopter, which is the unit of power. Now let us move to the next question. Again in the same box you will find another question which is saying that what is the power of a concave lens of focal length 2 meter. Concave lens, my dear, F is given to be 2 meter, but it will be minus. So power is the reciprocal of focal length, write it down. So which will be 1 by 2, but minus sign attached. How much it will be? 0.5 diopter. This is the right answer for this question. Okay. So these are the questions from the chapter which I have solved you. Now we will move to the exercise questions. Okay. So please note it, from now on whatever I will be solving, it will be exercise question. Let us start that also. If you see exercise question number 2, you will see the question to be like this. Let me read it out to the question as per the NCERT. It says that the image formed by a concave mirror is observed to be virtual, erect and larger than the object. where should be the position of the object? I have already solved this type of question for you once. Where should you put the object in case of concave mirror so that the image formed is enlarged and virtual? It should be between, yes, you got it right, focus and pole of the mirror. So let us see, is there any option? This is an optional question, okay. So between the principal focus and center of curvature, no. The option D will be the correct answer for this question. Question number 2, option D is the right answer, between pole and focus. Then only you will get this type of image. Now let us move to the next question. Next question says that where should an object be placed in front of a convex lens, to get a real image of the size of the object. So question number 3 was saying that same as the size of the object. So this is a condition where you have to put the object at twice f. If you put the object at twice f, the image will also be formed at twice f on the other side, and the size of the object and image will be same. So the right answer for this question number 3 is option D. Option B, sorry. Option B is the right answer, at twice the focal length. Now let us move to the next question. Next question is saying that a spherical mirror and a thin spherical lens each of have focal length minus 15 meter. You have a lens and you have a mirror and their focal length is minus 15 meter or centimeter, whatever it is. So what type of combination is there? So whenever you get a minus sign in case of mirror, the mirror is concave mirror, has got negative focal length, and in case of lens, which one it will be? It will also be concave lens. So the right answer is both concave. Both of them are concave. Both concave. If you see the option in the NCERT, you will find it out. Now let us move to the next question. Question number 5 saying that no matter how far you stand from a mirror, your image is erect. So which kind of mirror is this? If you are standing very far, but your image is coming to be erect. Spherical mirror produces real and inverted, and in few cases they produce virtual and erect images. But it is a condition where you have to get erect image only, no matter how far you stand. So this is nothing but which mirror? A plane mirror can produce that. You will get an erect image of the object wherever you stand. So the right answer for question number 5, you will see only plane. Question number 5, option A. This is also a MCQ question in the NCERT. Option A is the right answer. Now let us move to the next question, that is question number 6. Which of the following lenses would you prefer to use while reading small letters from the dictionary? From the dictionary, if you want to see the small letters in the dictionary, which lens you are going to use? Someone which will magnify, some lens which will give you an enlarged image. Which lens can give you an enlarged image when the objects are very close? Convex lens. So the right answer for this one is, in the question you will see convex lens of focal length 50 centimeter and convex lens of focal length 5 centimeter. So the one with greater focal length would be good for you. So convex lens of focal length 50 centimeter is the right answer. Question number 6, option A is the right answer. Convex lens of 50 focal length, 50 centimeter. Concave you cannot use. Concave you will give you small image only, diminished image. Now let us move to the next question. In question number 7, you will see that now you used to obtain an erect image of the object, that is question number 7, using a concave mirror of focal length 15 centimeter. The focal length of the concave mirror is given to be 15 centimeter. What should be the range of distance of the object from the mirror? Okay, what is the nature of the image? What is the image larger or smaller than the object? Draw the ray diagram to show image formation in this case. Okay, now you need to obtain an erect image using concave mirror only. This concave mirror, my dear students, if I do, this side is the opaque part, this is the principal axis, fine. Now this is the pole of the mirror, this is the focus, and this is the center of curvature. Only at one condition this will satisfy, when the object is kept between focus and pole. This is AB. Only at this condition only you will get an erect image. So light ray will strike, if it is striking parallel to the principal axis, it will pass through the focus, right. Now if it is striking directly, and it will go through center of curvature, right, striking and coming through the center of curvature. Now these two rays is divergent rays, it will not meet at a point at this side. So we need to meet it at a point. So I will extend on the other side. If I extend on the other side, this is how is this image will form, that is A dash B dash. So the range of the object should be in between pole and focus, and a virtual and erect image will be formed. In the question only they are asking to draw the ray diagram. So this is how the ray diagram is, and the focal length is given in the question is how much? It is 15 centimeter, right. So this is how you can solve this question. Now let us move to the next question. Now we will move to the question number 9. 8 was a theory question which you have to do it by yourself. I will just do problem solving. Number 9, it is saying that 1/2 of the convex lens is covered with black paper. Oh my God, it's a nice question. 1/2 of the convex lens is covered with the black paper, like that. And it is saying that will this lens produce a complete image of the object? Verify your answer experimentally, explain your observation. Okay. Now, even if it is half covered, the remaining portion will form its image. The image will be formed, okay, but the intensity of the image will not be that much if it was not covered. The intensity of the image will decrease. So image will form. Image will form definitely, but intensity will decrease. This is how we can talk about it. Now let us move to the next question. Now we will move to question number 10 of exercise question. It says that an object 5 centimeter in length is held 25 centimeter from a converging lens. Converging lens means which lens? Convex lens. Light ray converges. Okay. Now object of 5 centimeter in length. Height of the object is given to us 5 centimeter, right, and it is saying that its object distance is minus 25 centimeter, fine, and it is also saying that its focal length is 10 centimeter. Focal length is how much given for a converging lens? Focal length will be positive 10 centimeter. Converging lens means we know it is convex lens. According to sign convention, focal length will be positive and u is always negative, we know that, right. And it is saying that draw the ray diagram and find the position, size and nature of the image form. You have to draw the ray diagram. No, you do not have to do it. You have to draw the ray diagram. Okay, but then also we can find out the image distance in order to draw the ray diagram. So I will do it on this side. 1 by v, it is a mirror or lens. It is saying that lens 1 by v, that is convex lens. 1 by u is equals to 1 by f. So 1 by v plus 1 by 25 is equals to 1 by 10. So 1 by v is equals to 1 by 10 minus 1 by 25. So 1 by v is equal to 10 into 25, 25 minus 10. So it will be 15 into 10 into 25. So you will get, if I cancel it out, 3 times, 2 times. So 50 by 3. So V is equal to 50 by 3. How much is 50 by 3? It will be 16.6 centimeter. So 5, if you cancel it 1 times, on then 20, yeah, 16.6 centimeter. So you got your image distance to be 16.6 positive plus 16.6 centimeter. Now you can draw the ray diagram. Let me draw the ray diagram here. Ray diagram. Oh, it has moved little far. Okay, is it fine? Yeah, it's fine. So this is the convex lens, principal axis, optical center. Object is kept at 25 centimeter. Let me do the focus here. Focal length is given to be 10 centimeter. This is 10 centimeter. Object is at 25 centimeter. So this is my object, suppose AB, which is kept at 25 centimeter. The length of this one is given to be how much? 5 centimeter. Fine. Now how the ray diagram can be drawn? Well, if the ray strikes parallel, it will pass through the focus. So it will be F1, it will be F2, it will pass through the focus, and the other one will pass through the optical center, and your image is forming somewhere here, right? So this is your A dash, B dash, and the distance of the image, you can see it's 16.6 centimeter. It's little more than 10 centimeter, right? As we know, 10 centimeter is the focal length. Little more than that, which will be 16.6 centimeter, and focal length. That's all. This is the final answer. You can find the height of the image also if you want to, right? Magnification is equals to V by U is equals to H I by HU. With the help of this one, you can find the height of the image as well, but not necessary. But just need you need the diagram as per the question, and how far the object and image has to be placed.